He is been a ham since 1961, and he began his professional career in Denver as an engineer for radio station KOA. In 74, he began Sherwood Engineering, creating roofing filter and other upgrade kits for the Drake R4C, kind of a radio before my time. That led to performance measuring on other radios, and since then, Rob has refined the characterization methods, and he continues to this day. Rob's data, in my opinion, is a trusted source for how your receiver stacks up. Rob is a regular presenter at the Hamvention and other venues, and he operates his dream contest station on 10 acres of land east of Fort Collins, Colorado. With that, Rob, we got the recording going. Why don't you take it away? Let's see.
Okay, let me share here.
Yep, you should be able to just grab that. Okay.
Close all these other things out. Okay, go away.
What's going on here?
Okay, very good. And by the way, I now have 20 acres out east of Fort Collins, and I put a beverage up this summer.
Nice.
And going to start looking forward to that in the ARR 160 meter contest and see what it does. Totally new to me. So tonight I'll be talking about radios, obviously, but I do want to say focus on your antenna. Whatever you have now, if you can make it better, directivity is a really big deal. Let me move these all these pictures of you guys over on another screen. Get that out of the way. So are you considering a new rig? Okay. If not, how do you optimize your current rig? So I'm going to talk about something that's probably not mentioned much. Net receiver gain is important. And it's really amazing, the new direct sampling rigs, how different that is. So that has to do with when do you turn your preamp on, when do you use an attenuator, which maybe a lot of people don't use the attenuator when appropriate. So we'll talk about that. And then we have a discussion about that will be subjective about all the newer rigs that are on that list there under $1,600 and quite effective. So I've been measuring transceivers since 1975 or 6. I don't know exact year it started, and it was printed out in paper. And so it's a good way to weed out the radios you probably shouldn't consider. Now we have so many good radios, it's hard to believe. But then in the last 16 years, or maybe 16 and a half now, I've been out on the Colorado Plains about 45 miles east of WWV and doing rig evaluations in the contests. And if you're locked into a brand, you know, all the major brands now have some amazing offerings. So my chart that's on the web has sorted things by dynamic range. And I'll explain what that is in really simple terms. And that was defined in QST in Ham Radio Magazine way back in 1975. But then I refined it a bit. But the basic description means you feed in two signals, test signals, and you see where the third order distortion product equals the noise floor of the radio. Of course, you see distortion products for amplifiers in QST, third, fifth, seventh, ninth order, etc. So in the receiver testing, we just use the third order. And so that's the definition. You can also call it spurious free dynamic range. In other words, the spurious is just barely visible on a band scope, or here you can hear it, of course. So that's another definition of it. But you know, for years, once we got synthesized radios, which was great, they didn't drift, we had digital readout, but the synthesizers in the old days were basically terrible. So often for maybe 20 years, rather than the third order dynamic range being the limit in a pileup, it was the cleanliness of the synthesizer, which really wasn't up to par. So most of the radios, if you look on my chart and you see radios back in that vintage, which were all up conversion radios, they often were limited by the synthesizer. Not true today, thank goodness. So that's called reciprocal mixing dynamic range, and that was defined by the ARRL in 2012. And then they kind of forgot about it in 2013, but by 2014, it was that term was used with regularity. So initially, in 1975,
all the testing was done with 20 kilohertz test signals. They were 20 kilohertz apart. And as you know, when we're running a de-expedition, we don't have the QRM up the band 20 kilohertz or 40 kilohertz. So I've said, well, let's really make this more relevant to how we work a CW contest pilot. So I started testing radios with not only 20 and then 2. And then over the years, the league came on board and did a 10 and 5, and now they've done two for a long time. That's really a CW issue or RTTY issue. It's not a sideband issue. So when we had those up conversion radios, like my first one could have been a TR7, but anyway, the dynamic range was about 70 dB, 70, but now we've got all sorts of 100 dB radios. And then once the Orion 1 came along, up conversion began to die. We went back to a low IF like we had in the 60s, let's say. And so those radios pretty much 100 dB plus or minus some. So we've just got astounding performance in that aspect. Well, then along came the direct sampling radios. And right now we have Apache, the Elecraft K4, the Flex 6000 series, current ICOM products, and now even Yaesu. No roofing filter. So there's no difference when we make a measurement with wide spacing or narrow spacing, but they're all pretty much 100 dB, which is probably more than you need on a daily basis. 20 years ago, we couldn't buy a 100 dB radio, but now we just have a lot of choices. So what does a superhet roofing filter do? We still have superhets out there. Of course, the 101D is a superhet. When we had the up conversion radios, in other words, the first IF was above 10 meters or more likely above 6 meters, well, you could have a lot of signals in that 15 kilohertz bandwidth. But now with the lower IF, between, let's say, 5 and 11 megahertz, with a 500 hertz roofing filter, it's not very likely you're going to be in an overload situation because 99% of the signals won't get past the roofing filter. I was asked once, so, well, what if there are 2 signals inside your roofing filter, but let's say you're working a weak eye and you've got a station 100 hertz away and 200 hertz away. Well, that's probably not going to be a dynamic range limitation. It's probably going to be key clicks. That would be my best guess. On sideband, the splatter from a properly operating rig, let alone with an amplifier, is worse than the dynamic range of even the 70 dB radios. So when we're looking at a 2 kc dynamic range off my chart, which is the right-hand column, we're really not talking about sideband there. So there's the top 25 individual transceivers from my website. Now, this isn't starting with number 1 at the top and counting down 25. This is the top 25 models because, for instance, the K3 came out, the K3S is there. The direct sampling radios have more variation from sample to sample because the chip, the ADC chip, the analog to digital converter chip, they vary. And they vary more than we would see with a superhet radio. So there's second samples of several of the direct sampling radios on the chart. So here we go from 110 dB clear down to 86, which is still adequate almost all the time. There's the 990 at 87. So this gives you options that you can say, but what brand do I like? What price range? What type of an interface does it have? So for the last 16 years, I've operated 20 of these 25 radios in contests, sometimes multiple contests, but at least one major contest like we'll have this weekend. So how do you select a new radio? Well, I'd say, well, let's look at the top 25. That would be a good start. If you've been a Yaesu operator forever, Yaesu's made great strides in the last few years. Whatever brand, you can pick a radio that fits your budget from whatever your favorite brand is. The price range is astounding. Now we have a $900 Yaesu offering today. And of course, we've got the $1,000 7300, clear up to the sky's the limit. Ergonomics and user interface and the menus and the display, they're important to how it works for you. What I might want,
may find is different. So you really need to, if you're looking at a new radio, it'd be nice if you could sit down in front of it. Or is it ham radio outlet, for instance? You can only check out the radios that are sold through dealers. So that makes it a bit difficult to say, let's see a K4 or let's see a Flex. But that's the way it is. In an urban environment, you may find that noise is a big problem. So how the noise blanker works, the noise reduction works, might be a major selection choice. But antennas for me, or I would say that's really important. Here's my list of 4 things of importance. Location. Now, most people aren't going to move. I did move out to the country, but then your antennas, I'd say, are next. And in a contest, the operator skill, and then probably the radio, as long as you've got a reasonable radio. I don't know where all the Swan 350s went. So here's the thing that's different from all the years with superhet radios. They're pretty much consistent as to the noise floor, but this is not the case today with the direct sampling radios. That is without a preamp or without an attenuator. So these 6 radios, the dynamic range over in the right-hand column, pretty much around 100 dB. You'd never notice the difference on the air. But look at this noise floor. In other words, we'll call that the sensitivity. The noise floor is all over the map. There's a 22 dB difference between the Flex 6600 and the ICOM 7300. Now that doesn't mean one's right or wrong, it's just different. Now this is with no preamp. So surprisingly, like at my QTH out in the country, it's very quiet. On 20 meters, I would probably run a preamp with the Flex, where if I had the ICOM, if I was on 40 meters, I'd be running an attenuator. So you just have to realize what your radio's like, and the choice of a preamp or attenuator will depend on what your model does, because that variation is quite different. I want to talk about receiver noise floor. You'd like to have it 10 dB lower than band noise. So I'm going to discuss and give a demonstration of what you should try to do to measure antenna noise gain. And it's really simple to do. We'll talk about it in a moment. That will tell you, when do I need the preamp? You don't just want to say, if in doubt, turn the preamp on. Here's a chart from the handbook. Band noise versus frequency. And also in a residential environment, that's the top solid line. It's probably higher than that now. The dashed line is rural, and that is accurate today. Quiet rural, really, for me anyway, is where is my beam pointed? My noisiest direction is towards the Caribbean. The quietest is certainly to JA and maybe BK. So here's some numbers off that chart, so you don't have to kind of interpolate. And you'll see that band noise on 160 at night is about 30 dB or more band noise than on 10 meters during the day. So what's that mean? Well, of course, every radio is sensitive enough on 10 meters, let alone 6 meters. So it's too sensitive on the lower bands. So we have to take that into account. And that's where an attenuator comes in as a useful tool. So actually, this measurement was done 10 years ago, but it hasn't changed. And I did this for Gerald at Flex. He wanted to know what the band noise was out in the country, and likely in each direction. So I did this chart and wanted to compare it to that graph. So for instance, I highlighted in 20 meters, my noisiest direction is at about 135 degrees. On 15 meters, about 113. And on 10 meters, a little bit different, but still pretty much towards the southeast. And those numbers compared to the chart are within 1 or 2 dB. So this is reality. Now, that chart is with an omnidirectional antenna, but then with a Yagi, of course, we have the advantage of the rejection. And so the noise in my case, and probably yours too, you'll find a direction that's much quieter.
Rob, do you have a notion on what the noise sources might be in a particular direction?
Well, this is just atmospheric noise in this case. It's what's skipping in. And as opposed to urban noise, which can be all these electronics in our home, if you can get your antenna or your tower, I mean, the tower here in Denver that I'm at now was put up 1972. and it's right by the house. But then there wasn't much noise out of electronics back in that decade. But now the noise from your house with a washing machine, a dishwasher, a dryer with a microprocessor can cause all sorts of local interference, or solar panels, or you name it. So the urban environment is the tough environment. Ham came up to me after a contest university presentation the day before Dayton/Xenia and said, I looked in QST and my transceiver has the most sensitivity with preamp 2 turned on, so I run it all the time. That's a really bad idea. It's a tool. When you need it, you need it. But I talk to guys on 40 meters and they say, I've got my preamp on and the S meter is reading S8. Well, that's just craziness. So you want to use it when it makes sense. And I'll show you this test in a moment. For instance, the last ARRL DX sideband contest this spring, I just ran 10 meters and I didn't even have the preamp on, except when I was running JAs because a bunch of QRPers are calling me. But that was amazing. I'm almost always, well, let's say go back a few years when the sunspots were a whole lot worse. I always ran at least preamp 1, and maybe on CW if it was really weak stuff, preamp 2. But this past spring, I hardly needed it. I think attenuators aren't used when they should be, particularly with the radios that have all that extra gain. So like the ICOM, just for instance. So on 160, 80, and 40 at night, I'm running some attenuation. You haven't lost anything. So most radios in general are too sensitive below 40 meters, on 40 meters and below. And with the preamps, they're certainly adequate above. But consider these are tools. Preamps and attenuators are tools. You don't use them all the time. You don't leave them on all the time or off all the time. So here we're going to talk about antenna noise gain. And so you'll know on a daily basis whether the preamp makes sense. Let's say you're on 12 meters, whatever. So let's look at my 10-meter example here. This happened to have been a Pro 3. And you want to have access to your dummy load with any type of an antenna switch, built in or a separate one. And we want any kind of a voltmeter that you've got that has a dB scale. It could be a VTVM if anything like that exists, a Simpson 260 or a 630 NA or something like that, any kind of a meter with a dB scale. And you hook that up to your speaker, and then you're going to adjust the volume of your radio so that this dB meter reads -10. And then that's with the dummy load. And then we're going to switch to your antenna, a dead spot on the band, of course. And you want to know how much does the gain go up coming out the speaker as I switch from the dummy load to your antenna. Well, here on 10 meters with no preamp, it only went up 3 dB. That means the receiver was creating half the noise and band noise was the other half. Well, that's certainly not optimum. You don't want your receiver to be the noise limit. But then you turned on preamp 1, it was almost 10 dB. Perfect. So then you stop. But then you go up to 6 meters with no preamp, switching between the dummy load and my antenna. It only went up 1 dB, which you can hardly hear, but you can see it on the meter. Well, in this case, preamp 1 only went up 4.5 dB, which means a third of the noise is still coming from your receiver. Not optimum. But then preamp 2, 9.5 dB. Great. So it's also a good way to just be sure everything's working. When I go into the shack for the first time, let's say I was on 15 meters, I just click between the dummy load and the antenna, and I do it by ear because I'm now used to doing this kind of a test. You don't need your meter on there once or twice. And then you can say, okay, it's makes sense. But let's say you did switch to the antenna and it hardly went up. Well, maybe something went wrong with your antenna, water in the coax or who knows what. So it's a good way to keep track of things. So when is attenuation a win-win scenario? If band noise is running your AGC and that's pointless, then add some attenuation. Most of the radios, some you do it differently, and I'll explain that. You lose nothing if the AGC is running on band noise, if you reduce the gain. I like to set the AGC threshold about 6 dB above band noise. I happen to be on, at least on CW, a search and pounce operator. So I'm tuning between stations one after another. I don't want band noise to be as loud as every signal I tune in. But if I adjust that threshold so that the AGC is not running on band noise to any extent, then the signals kind of pop out of the noise. And now occasionally I'll have to turn the volume up like 2% of the time or something. So it really helps. On 160, I'm often running 18 dB of attenuation with an ICOM. Would I with that flex? No. And then 80 and 40, well, somewhere between 6, 9, and 12. So that's what I do. So how do you adjust the threshold? Well, if you have a flex, you have something called AGC-T. That's AGC threshold. It's a slider, and you adjust that. With the Apache, you have a horizontal line that you can move up and down so that you can let the band noise drop a noticeable amount and kind of leave it there. With the Elecraft, it's not very intuitive. The numbers are kind of meaningless, but you'll just have to experiment with the two adjustments. One is the threshold and one's the slope. With the Kenwood, ICOM, and Yaesu, use the attenuator. If the S meter is barely moving on band noise, that's a good starting point, or maybe it doesn't move at all. Now the 7300 that so many of us have, it's only got one attenuator, 20 dB. That works fine on 160, but that's too much on any other band. So just use the RF gain, because the way the RF gain works on a 7300 is just like an attenuator. It's the same point in the circuit. So there's just no point in band noise being as loud as 99% of the signals. So there's my station out 45 miles east of WWV. I really put a lot of effort into it. So directivity is a big deal. Those are all monoband antennas on multiple towers. And there was some interesting information from Frank Donovan at Contest University last year, or this year, this date and time period. He says, if you've got more than one tower, you don't want tri-banders on both towers, because you're going to be looking through one tri-bander with another, and it's going to really distort the pattern. But if you have monobanders, that's a different story. Frank has 9, I have 6. So that was something that Frank had mentioned before, but not in as much detail, that the interaction between multi-band Yagis can be a problem. If you want to talk to Frank about it, there's his email address. I'll send you guys a PDF. He's an excellent guy to talk about antennas, of course, contesting too. So now they're going to shift from technical stuff to subjective. I've got to talk about all these radios I've used in the last 3 years that are an option to consider, and some of them very reasonable priced. The main architecture today are superhead, and often superhead with a direct sampling scope, like the new Yaesu, for instance, or it's a direct sampling radio like the ICOM or the Apache or Flex or whatever, the K4. So the user interface today is pretty much an internal LCD or a computer screen. Flex runs on Windows or the Apple operating system. The Apache only runs on Windows. Unfortunately, Windows updates breaks things. So I'm still running an older version of Windows, so I don't have that problem. But then the limitation is, will your antivirus program still work on it? But that's where we are. One complication is Windows or the Apple software is not a real-time operating system. So if you're doing 2 or 3 things at once, or maybe the computer decides to index your hard drive, that can have an effect on computer-operated radios because it gets busy doing something else. One of my friends that runs an Apache 7000 DLE, and it's got the pure signal distortion reducing software. Sometimes if he says, well, I'm going to go look that up while we chat, and then suddenly his pre-distortion starts goofing up. So that's one of the complications with a computer that's doing multiple things at once. If it's just a standalone radio that's like an ICOM or a Yaesu or whatever, then that's not an issue. But what the interface that works for you may not work for me. So you really have to look at what you find is a good fix, a good mix. So here are the radios I'll be talking about, the ones that in the first half. They're ones that come out since 2020. The Yellowcraft K4D is $6,480, including the tuner, because all the other ones have a tuner built in. The FTDX10, $1,500. The 710, $1,000, or even one of $900. So it's just amazing what you can buy today. So I'll be talking about most of these from a contest user standpoint. So let's talk about Flex. For the past 2+ years, they've had a military contract, and they've been pretty much preoccupied with that. Hopefully, some of the new technology that's been developed for the military will trickle down to the ham projects, the ham versions of the radios. Hopefully, the project will be wrapped up by year end. I would say for the last 5 years, they've been mostly focused on remote and contesting. Not much has changed in, excuse me, in the way of DSP improvements. So hopefully that'll come. There are some bugs with the Flex software that have been around a long time. They do have a very loyal customer base. No schematics or documentation are published. That's sort of a sore spot for me. Even if I'm not going to fix it, I like to see the schematic. As of an email that came out maybe possibly over the weekend, the non-M models, in other words, the models that don't have a tablet front panel in effect, are starting to ship again. The Maestro, which is an external box that you could use in your backyard or in your hotel room, is slated to be shipping November or December. The M models with the display will probably start shipping the first quarter of next year. Apache, they don't have an enormous penetration, but they lead the world in certain aspects. Their noise mitigation, noise blanking, and noise reduction is amazing. You can actually run a noise blanker in a CW contest. With most times, everybody else's noise blanker is just useless when you've got 1,000 CW signals on the air. It's the only brand who currently has pre-distortion for sideband splatter reduction, and it's dramatic, like 20 dB. But the Apache is a fiddler's delight. They've got, God, there must be 100 things you can click on, and I don't know what most of them do. So don't consider an Apache a plug-and-play radio. But if it's you enjoy playing with it and seeing what all these options do, go for it. I do not recommend, though, that if it's your first HF radio, maybe you've been a tech and just became a general, or you just really haven't played that much on HF, I recommend a standalone radio, not a computer-controlled radio, and stay with 100 watts, not a QRP as your first radio. One of my brother-in-laws started with 2 5-watt radios, and he really had a hard time getting enough contacts. So QRP is an interesting niche, but I wouldn't start there. The Apache doesn't have great documentation. The manufacturer makes the radio. All the software that runs the radio is open source. It's all volunteer written. The noise blanking, noise reduction, and pure signal pre-distortion is written by Warren, NC0B, who lives about 40 miles north of me up in Loveland, Colorado. Because of the fact that a Windows computer is not a real-time operating system, consider a separate computer just for the radio. Not mandatory, but it'll reduce some problems that pop up here and there. Comments on the 7300. Now, I'm going to call it a game changer. That doesn't mean it was the best radio ever made, but it was the first direct sampling radio with knobs. You just plugged in the power, plugged in an antenna and a key or a microphone, and off you went. In the US and Canada, there were over 50,000 on the air. You can hardly get on the air without talking with a 7300. It has a good dynamic range. It operates much like the more expensive 7610. So if you were a 7300 user and sat down on field day with a 7610, you could run it. The ergonomics are pretty good. I like the scope display, even if it's small. You have my computer glasses. One nice thing about these four models that ICOM has, the 7300, the 7610, the 9700, and the 705, is they all pretty much have the same user interface. If you can run one, you can basically run the other. The biggest improvement was in 2001 when the scrolling feature was added, meaning, let's say I'm on 160 and I've got a 20 kilohertz bandwidth span of the display, maybe it's even 10. So I start the 1801 and work a station up through 1810. Then as soon as I tune above the upper edge of my span, it gives me a whole new span. And then I work that span and tune to just above that one, and I work the next span. So it's really simple and convenient to keep working up the band or down the band if you want to go that way. Yaesu FT710. This is Yaesu's first foray into a direct sampling radio. It's similar to the 7300, but the lab numbers are significantly better. I mean, it came out 7 years later, you'd hope so. The pricing, pretty amazing. The one that comes with an external speaker is $1,000. The one that comes without the external speaker is $100 cheaper. And you can see, compare it to the 7300 at $1,000. And the FTDX10, $1,500. They finally got the pricing that makes sense. When they first came out, the pricing didn't make any sense, but that's stabilized now. For me, the user interface could be better, but the radios work. In contesting the last quarter of 2022, October, November, December, I ran CQ Worldwide, ARRL 160, ARRL 10 meters, sideband and CW with the FT710 for 3 months. And even for just normal operating, rag chewing, whatever, I use these two radios. The 10 is the other one that I use for those 3 months. The lab numbers are like just a scotch below the 101D or the MP. The ergonomics are different, though, than the 710. And it has sort of the same user interface. So if you like it, great. If you don't, they're all the same. The 101D, the 10, and the 710. It is a classic hybrid superhet. In other words, it's got roofing filters, which have an advantage, particularly if you've got another ham half a mile away, let alone field day. So the hybrid simply means the band scope's direct sampling, but the rest of it's a superhet. Both the 710 and the 10 have an audio peak filter for CW. The 7300 does not. Again, the fourth quarter of last year, I ran the 10 during the 160 ARRL, the 10 meters, sideband and CW, and then finally the Stu Perry top band. I just did the 10 because it was easier to adjust the bandwidth on CW and the shift with the knobs on the 10 in comparison to the 710. So if you sit in front of both a 10 and a 710, it's almost like they were designed by different companies. The way you adjust the filter bandwidth of the shift is much easier on the 10 and not very flexible on the 710, particularly on sideband. If you want, you can set it up for 2 bandwidths, but you can't set it up for 2 IF shifts. The 10 has the volume control on just to the left of the tuning knob, and I bump it. If I'm right-handed, it's in the wrong place. On the 710, they move the volume control from just next to the PTO on the left to the right, so I don't bump it anymore. The band scopes and the waterfall do not recenter, and that's what wasted too much time when I ran the contest for those 3 months, was I had to manually recenter it every time I went past the span that I chose, whether it was 10 meters, it was 50 kilohertz, or if I was on 160 and it was 10. That could be fixed in firmware. Kenwood TS590S. Well, it's been around a long time. The S and the SG. The SG came out in 2014, 9 years ago. It's a good performer. It was probably the best bang for the buck back then. It has no band scope. Now that everybody's got a band scope, you can make one with like an SDR dongle and had a computer. It's easier to do on the SG than the S. The S came out in 2010, which just seems like eons ago. be reasonable price on the used market, maybe $600. Very user-friendly interface. And back then, when they came out, I operated the S and the SG on 160-meter contests along with the 10 Tech Eagle, and they all played very well. Will Kenwood bring out a new rig in 2023 or 2024? Well, they came out with a walkie-talkie at Dayton. So that's all they came out in 2023, but hopefully they'll continue with something in the HF world. The 590 SG came out in 14. The 890S that I've owned came out in 18. I love the way the waterfall works on the 890S. I think it was the best one of anybody's. You never lost what the waterfall was showing, because as you would tune, it would automatically update. If you tuned up a kilohertz, it shifted in such a way that you didn't lose anything of 90% of the waterfall. Unfortunately, the TS2000 was discontinued, and there was supposed to be a replacement that would have something that would compete with the 7300 for HF and the 9700 for VHF, UHF. It never came out so far. So every radio in the last 7 years has a band scope. So what will Kenwood do? I don't know. I hope that they stay with us, because Kenwood's known for great transmit audio, great receive audio, fairly simple user interface. And as I say on the 890S, I just love the way the waterfall works. 10 watts in a battery. Summits and parks on the air. As long as you can deal with a 2-pound radio, it's something else. Does operating either parks just in a picnic area, does it interest you? Well, consider the 705. Now, it is only a 10-watt radio with an external battery, but it covers 160 through 70 centimeters. Sideband, CW, FM, digital with a laptop, of course. They have a very cute tuner external that runs on batteries, and it works like an AH4 that, if you're familiar with ICOM, the auto tuner, it's very similar to that, except it's only rated at 10 watts. You can have a 23-foot piece of wire and a radial on the ground, a wire, and work 40 meters through 6 meters by punching a button. New Year's Day this year, I was on 2-meter sideband, and there was a station with a 705 at a park in the mountains in Colorado, 100 miles away, that was S9. It sounded like he was in the shack. Beautiful audio, beautiful signal. He had a 2 or 3 element Yagi that he had on a tripod. There's what it looks like. It kind of looks like a miniature 7300. It only weighs 2.4 pounds compared to a 7300 that's 9.3 pounds. So it's portable. If you're not of the type that says, well, I got to have a radio that weighs less than 1 pound. So it's 2.4 pounds. So some quick comments on the 705. It works like all the other ICOM radios. It's got lots of VHF features I did never get around to use. Ergonomics are consistent with the ICOM. So if you can run a 7300, you can run a 705. The display does recenter as you tune. I operated it ARRL 160, ARRL 10 meters in December of 2020. I was not running QRP. I was really evaluating it as a receiver. I was driving an amplifier. Okay, K4. Much of the firmware from the K3 got ported over to the K4. Some of the things needed tweaked. In the last 2 years, they made great improvements. When I used it the last time would have been 22 months ago. To be honest, it wasn't ready for prime time, but a lot of improvements have occurred. The R34 beta went gold just recently. So it took 4 attempts to get it stable. But of course, now will be what happens when R35 comes out in beta form. So new releases have bugs. That's just the way it is. It's one of the more expensive mainstream rigs at just under $6,500 with the tuner. The price did go up 9% on April 20th, but some of the Hamfests have been offering discounts, and I think they sold a bunch of them at Pacificon. Things that are still in the wings. They kept talking about the HD model. That would have roofing filters. It'll make it a super het, so it'd be kind of a hybrid. The pre-distortion that they've talked about still hasn't come out, and at Specificon I heard that it's still way down on the list. Transverters, maybe transverters will come out this year. There was some scuttlebutt about that. If you wanted to work 2 meters and maybe 70 centimeters. Very large customer base that went from the K3 to the K4. Fantastic reflector support, particularly from what we call TV Bob. Here's the one anomaly that I don't understand why it's this way. It was a design decision. But if you've just got a multi-band antenna, let's say tri-bander on the high bands, maybe a fan dipole on the low bands. Well, if you're on 20 meters and you've got the K4D, so you've got a sub receiver, and you want to see if 10's open, like next weekend, you can't listen to 10 meters with the sub receiver when you're on 20, because the transmit low pass filters in the receive path and kills the signals on 10 meters. Now that's kind of unusual, but apparently that even existed with the K3, which I didn't know till recently. Let me make a quick comment. People call me all the time or send me emails and say, should I upgrade from a 7300 to a 7610? Now, a 7610 supposedly will have digital pre-distortion sometime this year when the PW2 amplifier ships, but it's supposed to work just by barefoot without the PW2. We'll see, but that's vaporware at the moment. The 7610 does not have noisy relays for the TR switch, and you can key your amplifier with a FET. It has an audio peak filter, which the 7300 does not. Of course, it's got dual receivers. Every DXpedition is split, and so it's handy to have dual receivers, not mandatory. It's got many more physical buttons, a larger LCD screen, and we've got a button for each band. It has 2 transmit antenna ports, 1 receive antenna port, which I'm going to be playing with my new beverage. If you want an external monitor, personally I don't, but a lot of people do. It's got a DVI output, so you can put the biggest monitor you can put in your shack. The fan's much quieter than the 7300. Since it has 2 receivers, you really need a separate tuning knob. And so they sell a separate tuning knob for $300. Seems kind of high, but the flex knob costs about the same. The K-Pod knob from Elecraft they're all about $300. If you only operate sideband and FT8 and you've got a 7300, stay put. There's a picture of me working Swains Island on 12 meters with the split screen, of course, and the dual receive. It was like falling off a log. They came in for like 4 hours at S7, sometimes S9. I couldn't believe it. So that was fun. So that's how it looks like with the dual receivers. And notice I didn't even have the preamp on. Just astounding. So we're wrapping it up here. Important factors to consider. You know, my chart on the web, they're sorted by close-in dynamic range, meaning 2 kilohertz spacing for CW pileups. But you don't buy a radio with just one number. It's got all sorts of numbers there, and then we've got all this user interface stuff. So how does a given radio work as far as the fatigue factor? Is the audio clear? Does the AGC work right, or does it do screwy things? Does the noise blanking work? Your QTH, that might be a defining issue. The Flex is probably the best for remote. Unfortunately, about a month ago, their remote server went down and you couldn't work remote at all. And then it even was affecting people at home because it couldn't phone home. So that was kind of a stub your toe, but it's fixed. Apache has pure signal and the noise reduction that is pretty impressive. Both require an internal or external computer. Ergonomics are really the defining factor today. I mean, if you say, well, the radios are going to work in a pileup, so then what do you decide on? Well, how does it work for you? Does the speech processor work? The K4 one 22 months ago, the speech processor didn't work. The EQ didn't work. The CWX selectivity didn't work. Well, that's all fixed, but it took quite a while. Do you want a standalone radio that just plug it in and it works? Do you want to deal with the computer? is the firmware updated regularly. I mean, every radio today I consider an SDR. Firmware runs the world, and it can be improved, fix bugs, add new features. Is warranty service done well? Having owned a TS990 and a TS890, this was an issue because they used to have a very good service facility in Virginia that was closed down. The one in California was terrible. Now they have a good service provider in New York. So we really have to have service from the OEM. And can we get parts once it goes out of production? This might be an issue for K3 owners. And the bottom line, I always say, this is a hobby, whether you're contesting, rag chewing, whatever. Did you enjoy the last hour or two, or maybe last 20 hours in a contest? Did you enjoy it? Was it fun, or was it a struggle? If it's a struggle because the radio doesn't talk to you the way you want it to, consider another radio, because it is supposed to be fun at the end of the day. I'll send your club a PDF of this, and they can distribute it on their website or whatever. I stop sharing and shoot it to you guys for Q&A if anyone has a question.
Yeah, thank you, Rob. I think Chuck has a question. Go ahead, Chuck. You're muted.
Press the space bar. Press your space bar, Chuck.
Didn't,
Hold
yeah,
it. There you
I'm not muted now. I sent this question to Bob as a text message, but I'll take the opportunity to ask it in front of everyone else. Bob, when you were talking about received noise levels, you described them in dBm. What was missing from that was it really should be dB with respect to watts per hertz. But if you would tell me what was your received bandwidth, then I can understand those levels.
Okay, well, everything today, when we're talking about noise floor, is in a 500 hertz bandwidth. That was just the standard that they did in 1975. So it's always, whether it's in QST or RSGB or my website, if it says noise floor, it's in dBm in a 500 hertz bandwidth.
Thank you.
Sure.
Rob?
Yes.
Hi, Bob KQ2M. I have a question for you. First of all, thank you for your presentation and also the charts and graphics. Very, very helpful. I'm looking at I'm thinking about the FTDX 101 versus the FT 101. Let's see, the FT10 versus the FT 101 DX, I think. The FTDX 101 was shown with I believe, a noise floor of 110 dB versus 107 for the FTDX 10. Is that something that we're really going to notice at all on the air? I mean, one obviously has a better range than the other, but for practical purposes, are we going to notice that on a noisy band, or are we going to notice that on like a dead band?
Well, I don't think 3dB is going to be noticeable very often. Maybe on 10 meters or something. Let me bring up my website so I can look at those, because all three of the AZU radios are right there near the top. I didn't remember there was that much difference, but let's look. So in that 500 hertz bandwidth, again, let's just look at preamp off, because you can always turn the preamp on. I'm showing the 101D or the MP, which on receive is identical, the noise floor with no preamp minus 127. The 10 was 126, and the 710 was 127. So I don't see any difference at all there. Let's with it in 1 dB.
Okay, I must have been looking at something else then, or I got the numbers confused.
No problem. See, I would hope that when someone looks at that page that has 150 radios on it, they're going to look at more than which one is it, how far is it down from the top. In that one column that says dynamic range, narrow spaced, there's all sorts of information there talking about the synthesizer. Now, because reciprocal mixing dynamic range didn't come out till 2012, and it really didn't become common until 2014 and later. I don't have that data on the website, but I have something you can convert to it. And it says right up there, RMDR didn't exist before 2012. So if you look at the LO noise in dBc per hertz and subtract 27 dB, you get RMDR. So of course, you can just compare the radios, the numbers that are there. And if there's blocking information, there's AGC threshold. And so there's a lot of data there beyond just that one column that people focus on.
Which, if I may ask a follow-up question related to this, I have two old legacy FT101 MPs, which were notorious for very strong signal conditions like 40-meter phone in the DX contest, of the signals becoming almost like a mush, although that was helped significantly by the use of the roofing filter. Which of the various measures that you show on your website would be helpful for us to get an idea how it might sound, a receiver might sound under those conditions?
Well, that would be a case where you want to look at the 2 kilohertz dynamic range. The mush factor was even an issue with the K3, and so K4 people say it's better. The MP goes way down is probably about a 70 dB radio. I'd have to find it, but I assume you're talking about CW for the most part.
No, I'm talking particularly on phone.
Well, then the issue there would be the fact that it's an up conversion radio. It has a 15 or 20 kilohertz first IF at something above 10 meters, or maybe is above 6 meters. So that's a lot of stations in plus or minus, let's say 10 kilohertz. So that would be its limitation. But remember, there was one case where WRTC was won by some Russian hams with the MP. So they probably learned to use their attenuator judiciously. On 40 meters, if you're not running 6 or 12 dB attenuation on any radio, you're stressing the radio more than is appropriate, because there's nothing to lose. I mean, the band noise on 40 meters in that 500 hertz bandwidth as a standard is about a minus 100 dBm. And the dynamic range of and the sensitivity of all these radios is like 25 dB lower than that. So there's no need for a difference between band noise and receiver noise floor being 25 dB. There's where the attenuation, let's just say 12 dB, is your friend.
I see what you're saying. Thank you.
Hey, Rob.
Yes.
Jack, W1WEF. What's your radio of choice today?
I happen to have 3 7610s. That in the last 10 years, I've owned the TS990S, the TS890S. They both suffered some EMP damage from a nearby lightning strike. And luckily, I haven't lost an icon. But that's just what works for me. And I'm not saying that it works for you. People say, well, look at your chart. I should own the one that's at the top, which would be a 101D. But the ergonomics don't fit me. So whether it's a 100 dB radio or 110 dB radio or a 90 dB radio almost makes no difference. It comes down to the features, the stability of it, particularly if it's computer controlled and things like that. So, but I have 3 operating positions so that I can, like in this case of those 2 new Yaesus, I tore down operating position 1 and operating position 2 and put the Yaesus in there for 3 months. Operating position 3 was still a 7610. So then when something seems funny, I can always go back to a radio that I'm used to. Doesn't mean it's a perfect radio. No radio is perfect. But if there have been cases where there's just something wrong with the radio. Well, for instance, when the K4 first shipped, and I used it then like 8 months later, 22 months ago, the CW selectivity was awful. And I said, well, something's wrong here. So I switched over to the ICOM, which worked like I expected. Well, then eventually Wayne fixed it and fixed the selectivity, or the shape factor, in other words. So I always have something I call a reference radio that I know how it works. I know what its weak points are, but that's That's how any new radio that comes out, like the 705, I tore down a TS890S and put a 705 in there. There was, 5% of the size and ran it for 2 months.
I only have two 7610s and I love them.
Well, there are a lot of radio for $3,250 now. Two of mine go clear back to the first month they shipped. The other one, two of them bought used, and the one that I bought like 2 years later is going strong. So I've had no troubles with them, and they work for me.
Thank you.
I'm going to pull on a thread that Bob was touching on a little bit on the phone versus CW specsmanship we've got going on, right? So for the, we're talking about the blocking dynamic range being important, and that for phone, some of these numbers aren't, you're limited by something else. And I guess I'm a dummy about what exactly is the difference between the specs on phone versus specs on CW, and what's our limiting factor on these radios for phone?
It's really the guy that's 3 to 5 kilohertz away,
Yep.
Assuming the guy's not flat topping, he's linear, and then he's 50 kilohertz wide.
Yeah.
So the typical guy overloading his linear is probably 20 kilohertz wide, but you can see it on the band scope. And that's the one thing today. Every radio's got a band scope that's been made in the last 7 years, maybe 10. And when you're seeing splatter on the band scope, the guy can't get away with saying, I'm overloading your receiver. That band scope tells you reality.
Yeah.
So for what we're hoping, I mean, Apache's had pre-distortion now for approaching 10 years. ICOM's talked about it recently in reference to the PW2, but it really has nothing, we hope, to do with the PW2, because they do say it's going to work as a standalone transceiver. Let's hope that's true. Flex has talked about it for 10 years. I know that Gerald said, well, we've got dual receivers, we can do it. Still hasn't happened, except maybe in their lab. And Elecraft has said the K4 will do it, but when? And when they were asked at Pacificon about it, well, it's not near coming out soon. ICOM is supposed to ship the PW2, and there are a firmware update for the 7610 that will allow it to do pre-distortion. Let's hope that's reality. The difference is quite significant. When I get on the air on Saturday mornings at 8 o'clock on 75 meters with a bunch of my friends here in Colorado. The one station W0IVJ that's running the Apache with pre-distortion, his signal, he's like 20/9. My band noise is S3. His signal is like a rectangle. It's just astounding. And then we get someone else talking. In this case, it was a K3 and a KPA 1500, and he's 4 times as wide. So now you're not going to hear the 4 times difference unless you've got a heck of a good signal to noise ratio, but that's where the limitation is. The ARRL is almost a year ago now has started something called the Clean Signal Initiative. I happen to be the vice chair. It was discussed at the Dayton Hamvention, and there was an article in QST, and there's going to be something, I think, in first quarter discussing what this group has done. And it's really a spin-off of the article I wrote for QST in, I think, November 2019. It's time to clean up our transmitters. The receivers have improved phenomenally in the last 20 years. The transmitters have not at all or got worse. The LD MOS amplifiers are not clean. So if we could get, let's say that ICOM gets with the program and they ship the firmware update and they actually have significantly cleaner signals before the end of the year, maybe that will be a prod to get Flex to do it and Elecraft to do it. Then we just have to convince Yaesu and Kenwood to do it. So this would be so much to clean up our bands, particularly in contests when people tend to get carried away.
Right. Okay. So that's what I was misunderstanding. It's really the environment you're in and the nonlinearities of the sideband signals so you got crappy signals you're dealing with coming through your excellent receiver.
Exactly. I mean, we should be able to work in 3 KC channels, and we all kind of work channelized. I mean, who's operating on 0.2 319 hertz anymore. It's all at 1 kilohertz segments. That's fine because then the guys don't know how to tune you in. We can all more or less be on frequency, but I should be able to have a guy up the band 3 kilohertz and not bother me, but that's not always the case.
Yeah. Okay. Thanks very much.
Rob,
Rob?
do you find some of the radios are challenging the capabilities of your test instrumentation these days?
No, but
No?
that's been a progression. So I started testing radios in 1976. By today's standards, it would be totally obsolete equipment, but it was good enough for the day. And then things improved, and I had to get better signal generators and better isolation. And then so that was a new stuff. So I went from like HP 606 and a 608, which I could only do 20 meters. Then I had a pair of 8640s. And then that wasn't good enough. Then I went to a pair of 8662s from HP, and then that wasn't good enough. Then I went to a pair of 8642s, which is currently good enough for 110 dB radios. So that isn't an issue. One thing, since someone mentioned blocking, if you look at a K3 as an example, it says 150 dB above the noise floor. That is measured with a super clean Wenzel oscillator. On the air, we're never going to see blocking numbers of 150 dB because nobody's transmitter is that clean. That doesn't mean we don't love a 150 dB number, but if on the air we really get 135, we're going to be happy. Because in that case, the other guy's signal is the limit, not my blocking in my radio.
Rob?
Yes.
Question, among the various radios, which do you find to be the most effective in terms of filtering out line noise and a variety of other electrical noises? Like, for instance, the Yaesu FT101MP has an effective noise blanker until you get loud signals nearby, and then you get terrible distortion. So that kind of defeats the purpose of having it, especially in crowded contest conditions. But among the various receivers, which do you find has the best noise blankers, but without the near loud signal problem?
As I think I touched on, the Apache has something that Warren calls spectral noise blanker. Instead of looking at the whole first IF bandwidth, like on an up-conversion radio, or the half the band with the direct sampling in general, is spectral noise blanker, and this is be mostly a CW situation. The blanker only looks at the CW bandwidth. So let's say it's 500 hertz or it's 200 hertz. So it doesn't false trigger at all because he's not looking beyond the bandwidth. But he has to do a lot of filling in, because when it blanks, instead of just having a hole, he interpolates between the first data point before the noise pulse and the last data point after the noise pulse, and he interpolates it and fills that in rather than just having a blank thing. So I found the only time I can use a noise blanker in a CW contest is with the Apache, with strong signals. Now, if the band's virtually dead, it's a different story.
But I'm sort of wondering. I mean, I just did a forced upgrade because of a lightning event from a Pro 3 to a 7610, and the noise blanker on the Pro 3 was decent. The noise reduction I thought was worthless, and I was sort of blown away when I tried a K3 a couple of years ago and was like, oh wow, the noise reduction actually works. But I'm curious because I haven't tried it yet on the 7610. How is it? And maybe a more important question is there any way of rating? Is there any way of rating the behavior or the usefulness of noise reduction?
Well, let's talk about blanking and noise reduction separately. I think from a blanking standpoint, everybody's noise is different, so I don't know any way to do that. I can do it in the lab, but it's like meaningless.
Yeah.
But it's adjustable in the 7610. So you hold the button in, and you got three things you can adjust. The noise reduction, I find that the more you turn it up, the less I like it. So for CW with the 7610, I may run it on 4 out of 10. On sideband, I only run it at 2 out of 10 because I don't like the self of the sound. I think you've still got the problem even with the 7610 that it can false trigger on a pileup of CW signals. But I do like the noise reduction better on the 7610 than the Pro 3.
Yeah, okay. Yeah, I mean, thanks. I mean, my big problem, which suddenly disappeared when some other big storm destroyed a pole pig in the area, which was actually quite nice because I wasted a fair amount of time trying to find trying to find what was causing my noise problem on 160. But so hopefully I won't need it. My area isn't that bad, but I'm sort of like, okay, so if I ever need that tool again, you know, what do I want? So thanks a lot.
Sure.
All right.
Great. And of course, that's a subjective comment. A friend of mine runs it on 9. I can't stand to listen to it on 9. So it's just what your ears tell you to do.
Excellent. All right. Any final questions? All right. Rob, that was excellent as usual. Thank you so much. Hope to work on the bands this season. Always looking for you on 160 and whatnot. So very good. This point, I think we could call this presentation a wrap. You're welcome to stay around or maybe head out. We're going to be doing some nuts and bolts of the club at this point. So it might not be too interesting for you. So thank you again.
Well, appreciate the invitation. And my wife just got home, is fixing dinner. So it's 7 o'clock here. So I'll go have dinner and you guys enjoy the rest of the evening. 73.
Excellent. Thanks again.
Thank you
so much. Thank
Bye-bye.
you. All right. That was a good refresher. What he does. His website is actually pretty easy to find, where he has this big table, lots of good information there, and we'll get that presentation posted.